The history of cosmic model. We always think of astronomy as a model, and as we understand, we improve this model along history. I would like to start with two statements from two very famous scientists worldwide. The first one is Stephen Hawking. Did any one of you heard about Stephen Hawking? Good. There are 3-4 people. Stephen Hawking is considered the natural extension of Einstein, and he is still living up till today. He is completely paralyzed. His hands, his legs, his everything. He's on a wheelchair. The only thing that is working in him is his mind, and he has a wonderful mind. So they designed a specialized system. The scientists designed a specialized system for him so that they can communicate with him through this system on a kind of keyboard with a computer and so on. So he wrote a very famous book that is always the bestseller called A Brief History of Time, from the Big Bang to Black Holes. In this book, he talks about the beginning of the universe, when the Big Bang happened, up till the discovery of the black holes. I don't know whether we will have a chance to talk about it or not. But in any case, the challenge of this book is that it's a very scientific book, but it does not contain any single equation or any single notation. So he did it in a very fluent way so that anybody can understand what he's talking about. So in a statement he said, which is very important for our way of thinking, that there is no theory that is absolute. There is no theory that you can consider a constant or the same all over history. Even the laws of Newton, that we consider them consistent all the time, then Einstein came and changed this concept and so on. So even if we say 1 + 1 = 2, this is not an absolute fact that we can deal with all the time. He says a theory is just a model of the universe. This is what he calls a theory, or a restricted part of it, and a set of rules that relates quantities in the model to observations that we make. It exists only in our minds. So many people, they make mistakes that they say, this is a theory of Mr. So-and-so, it's absolutely correct. There is nothing like that. This is absolutely correct up till now. Maybe tomorrow it will prove that it's not absolutely correct. So it exists only in our minds and does not have any other reality. A theory is a good theory if it satisfies two requirements. It must accurately describe a large class of observations on the basis of a model that contains only few arbitrary elements, and it must be definite predictions about the results of the future observations. We say that the theory is correct when it explains many things that we see around us. So then it's correct. But one day, when it proves that it cannot explain some phenomena, then we have to stop and see if the theory is absolutely right. And then he said any physical theory is always provisional. As I said, a theory is provisional till we find another theory that overrides this one. The eventual goal of science is to provide a single theory to describe the whole universe. So this is a very important concept. In fact, the scientists are searching all the time, trying to find out a general theory that explains everything. They call it sometimes the theory of everything. And in that aspect, if we look back in history of science, we find that at the beginning, for example, we were thinking that magnetism and electricity are separate things. In fact, at the beginning, we discovered that there is a piece of a stone that we take from the mountain, and then when we find any small piece of iron, then it attracts it. And then we call that magnet. And then somebody else, after 100 years, discovered that if you put some chemicals together into a container, then it generates electricity. We called it electricity, an electric current that goes in the wire. And we, all the time, we were thinking that these are two separate entities. And then we discovered that this magnet, if we move it near a piece of wire, then it generates current. And that this current, if we make it in a form of a coil and pass the current in it, it generates magnetism. And then we discovered that electricity and magnetism are one thing, and we call it electromagnetism. And then we go on and on, things combine together till, for example, at the time of Einstein, he has his famous equation. Do you remember the equation of Einstein? E equals mc squared. You all know by heart. And this is a relation between energy and matter. We were thinking that matter is something, or mass is something, and energy is another thing all the time. And then we discovered that energy, mass is a concentrated energy, and energy is nothing but mass that is unbounded and so on. So he combined mass and energy. And before that we combined electricity, and so the laws are the same. We call it electromagnetic laws, and mass and energy law, and so on. So we are combining things into single laws. So scientists are hoping that finally we can combine all the phenomena of the world around us into one single model or one single equation. So this is a general concept of 20th century of Stephen Hawking. But in the meantime, we see an Arab scientist, Ibn Haytham. In fact, at the time of the Renaissance, this must be 432 Hijri, that means more than that, of course. In any case, Ibn Haytham, one of the Arab scientists, and the Arab scientists, as you see, they all, if you want to have, as I said, advancement and civilization and so on, you have to have an open mind to accept new ideas. Then he said, فطالب الحق ليس هو الناظر في كتب المتقدمين المسترسل مع طبعه في حسن الظن بهم، بل طالب الحق هو المتهم لظنه فيهم، المتوقف فيما يفهمه عنه، المتبع الحجة والبرهان لا قول القائل الذي هو إنسان. That means he says, don't just follow what the others said before you and you just take it as a fact. In any case, and then comes a very important phrase that he says, والواجب على الناظر في كتب العلوم إذا كان غرضه معرفة الحقائق أن يجعل نفسه خصما لكل من ينظر فيه. This is a very important phrase because he says, teach yourself when you read something, you put yourself as adversary of that thing, and then to decide whether it's correct or you really suspect it and you have other ideas. In any case, and it continues on. So the thinking, the scientific thinking is the same all the time. It coincides almost with what Hawking said, in the sense that there is no theory that is absolute. That's why you have always to challenge theories in order to come with a new one or a modification one. And it's not necessary that you challenge a theory to come with another one. Even you challenge it in order to be satisfied that it's correct finally. Or no, it's not that much correct, and we will, and I have another idea. That's why we should accept the ideas of the others if they are different from us also. Okay, there is another important thing that I would like to get to your attention, is what another scientist called Francis Collins had made recently in one of the articles in the Time magazine. Francis Collins is the one that made the deciphering of the genome or the DNA. You know the DNA, huh? So the DNA, in fact, is the computer that is inside us, the memory of the computer that is inside us. It stores all our features and everything. And we can read it as we can read now. We started reading it as we can read the code of the computer. And he is the one that had read really the most of the parts of, or the phrases that are in the genome. So he is a very faithful person. He said the God of the Bible is also the God of genome. So he can be worshipped in the cathedral or in the laboratory. This is a very important point, is that he considers that his work in science is part of his faith and part of his religion. It's not only that he goes to the cathedral and pray there, but also as he works in the laboratory, this is part of his religion and part of his. And this is very important. And we know that in Islam and in Masihiyya and in everything, that the books calls us in order to think and to act our mind. تفكروا انظروا إلى السماء كيف خلقت انظروا and so on. And so because I work a lot in astronomy, I just made my own statement. I say the God of the Quran is also the God of astronomy. He can be worshipped in the mosque or behind the telescope. Because really behind the telescope, and when you look at the sky and so on, you will discover realities that you cannot imagine. And this helps you in understanding the universe, understanding God, and worshipping Him better. Okay, so we are talking in these two presentations about different aspects of astronomy. Astronomy, in fact, it has different aspects as we see here: astronomy, astrology, archaeoastronomy, astrophysics. The difference between them is simple. Astronomy is how we can see the sky. It's exactly equivalent to geography that we have on Earth. In geography, we can describe exactly the content of the surface of the Earth anywhere. We say this city is at longitude so and latitude so, and it has that amount of inhabitants, and this country is so and so and so on. The astronomy is exactly the same thing. We look at the sky as we look at the Earth, and we say here are some stars in the sky. Each star is at this longitude and at this latitude, and also has this amount of brightness, and it's connected to a group of stars that is called so and so. So it's a kind of, we can say this is the geography of the sky. And then astrology, as I said, this is Tangim. Tangim is trying to find a relation between what happens in the sky and what happens in our life. A small example of that, at the time of the ancient Egyptians, and this is a very important thing, they discovered that there is certain star in the sky. It's called Sirius. It's the most bright star in the sky. It does not appear all the time in the sky, but it starts appearing in July. When it appears for the first time, just a few days after that, the Nile flood starts. So they made this relation. When this star appears, the flood comes. They thought that this is the reason of this, and this star Sirius, they related to their god Osiris, etc. But in any case, they made this relation between a star and a phenomenon that happens on Earth, which is the flood. And then, I'm just giving one example. People, they do many, and all the day you read in the newspaper, البحث والكلام ده, برج العقرب وبرج المعرفش ايه, and so on. And all this what we call astrology, sorry. So there is a big difference between astrology and astronomy. Astronomy is pure science. Astrology is culture, is folklore. Bon. This third thing is archaeoastronomy, which is the history of astronomy. So we're talking about geography, and now we are talking about history. Is that astronomy, how it was seen in the time of the pharaohs, and how it was seen in the time of the Greeks, and how it was seen in the time of the Arabs, and so on. And then astrophysics, this is physics. That's like anatomy of a person or a human being. we look at the stars and see the course of life, how the star begins and how it grows, and like civilization, as I said before, it has a rise and fall. The stars, everything in the universe, it has the same pattern. It has a rise and fall. The star starts forming, and then it becomes a star, like the sun that we have. The sun is one of the stars, of course, as we know now. And then, but we are talking about millions of years. Huh? And then at certain moment, it started collapsing. Huh? So it has this lifespan that astrophysicists, they study it and how it happens and what's the physics behind it and so on. So we will be seeing now immediately the history of the cosmic model, and then in the next lecture we will talk about the content of the sky. History of cosmic model. In fact, the history, I was choosing a moment which is the moment of Galileo, when he changed the thinking of people in astronomy or in the cosmic model, but it took several generations or several civilizations to modify this model. So the first people that started putting really theories for that and in a form is the Greek school. We always talk about Plato, about Aristotle, and so on. And then came the school of Alexandria, when the Greek came to Alexandria and the Ptolemies governed Alexandria, and then we formed the Library of Alexandria. There was a lot of work in astronomy that was developed at that time. And then there is the Arab scientists, I'm very fond of one of them, who is Sufi al-Razi, and there is a Battani, and there are many known, and one of them is Omar al-Khayyam. He was an astronomer also. And you have seen, I think, when you visited CULTNAT, you have seen the Star Riders, the exhibition about the astrolabes of the Arabs. And then the Renaissance, or Asr al-Nahda, the time from 800 till 1500, so about 700 years. The knowledge was mainly in the Arab field, in the Arab countries, and then it became, Europe took over, and the famous scientists like Newton, like Galileo, started appearing. And then the modern times, which we live now, which is, from my point of view, it started in the 19th, in the 20th century, beginning of 20th century. So as you see, knowledge migrates from one civilization to the other, and everyone adds to it, and till what we have now. This is what I call الحضارة الغالبة, or the dominating civilization. At certain moment it was the Greeks, another moment it was, before that there was the Egyptians and the Babylonians, etc. And then Alexandria, and then the Arab civilization, and then the Renaissance, and then the modern times. And now, of course, we are living domination of the American, the Western civilization, and especially the American civilization. If you look around, you will see that, for example, the Far East is developing now. Maybe they take over after a while, or we don't know where, but you know that these cycles, it takes hundreds of years. It's not that simple. So in the Greek school, we talk, I said it started about 500 BC. Remember that the ancient Egyptian civilization started 3000 BC. The Greek civilization started more or less about 500 BC. And in the Greek civilization, there was Plato, or Aflaton, as we know it in Arabic, that was between 427 and 347 BC. And that was a very important moment of thinking, because he formed what we call academy. Everywhere now we talk about an academy. He invented even the word academy, whereby we could learn more about universe by logic and reasoning. For more than he taught people how to think, mainly more than how to observe. And he says that the universe must be very logical and very uniform, so everything must be spherical and everything must move in a circular form. So he tries to put a model for the universe that is perfect in a form that it's more, everything is spherical, everything goes in a circle, and so on. But after a while, we saw that this is not the perfect thing, but we have a modified thing from there. And then came after that Aristotle, or Aristo, as we call it in Arabic. And he was very important because he has put a model for the universe for the first time in a written way. He said the universe is finite and bounded by a sphere that contains fixed stars. They all thought that the universe is a sphere that has fixed stars in it, and the stars that are point. We didn't know at that time that stars and the sun are the same thing. We thought that they are just small points in the sky. And outside the stars, there is nothing, nobody, no space, no time. And this is the model that he invented, is that the Earth is in the middle of the universe, and it's surrounded by the moon, by Mercury, by Venus, by Mars, by Jupiter, and by the sun. The sun is revolving around the Earth. And then there is an outer sphere that is full of stars. That's it. But remember, at that time they were talking about 5 planets only. These are Mercury, Venus, Mars, Jupiter, and Saturn. Now we are talking about 8 or 9. We added Neptune, we added Pluto, we added many other ones. Why in the old times, all the time, in the old times up till Galileo, we were talking about only 5 planets, and now we are talking about more? Do you have an answer to that? All the time we were talking about, in the old times, about 5 planets only. Now we talk about 8 or more. It's simply because these are the planets that we can see with our own eye, but not with any instrument. The other planets, you cannot see them with your bare eye. So after Galileo, we started inventing the telescope, and the telescope is getting bigger and bigger, and as it goes bigger, we can see deeper in the sky, we can see fainter objects in the sky, so we started seeing other things. So in fact, the 5 main planets that I'm talking about, that were mentioned in all history and in all civilizations, are the ones that we can see with our naked eye. But the other ones, like Neptune, like Pluto, we cannot see them except if we have a good magnifying instrument, like a good telescope. So at that time, that was how they looked at the sky. The Earth is the center of the sky, and around it is the other planets, including the sun. And then came, I told you that at the time of Alexandria, or the Ptolemies, there were many scientists, especially in the field of astronomy. There was Aristarchus. When you go to the Library of Alexandria now, they talk a lot about these scientists, and they started showing them. So Aristarchus, in fact, what he did, he tried to measure the distance, in a way, the distance between the Earth and the Sun, and between the Earth and the Moon. And he made some measurements that were not correct at that time, but that was the first measurement that was done at that time. And then came Eratosthenes. He lived in Alexandria. He's an Alexandrian. We always talk about him as an Alexandrian. And he did a wonderful experiment that now in the Library of Alexandria, they have a discovery center there. They do this experiment every year. This experiment is that, you know, Madar al-Gadi, Madar al-Saratan, and all these things. In this Madar Gadi and Madar al-Saratan, the sun is perpendicular to the Earth at this Madar, at one of them in the winter, and at the other in the summer, and then in between at the equinox it's at the equinox or at the equator. So in fact, Aswan, the city of Aswan, is lying on the Cancer circle. So at that time, in the summer, the sun becomes perpendicular to this point. So if you have a pole like this, then it doesn't have a shadow. So if the earth is curved, then if you go to Alexandria and you put a pole there in the same date, then it has a shadow. So it has a shadow in Alexandria, and it has more shadow if you go north to the North Pole, etc. And if you go to Aswan, it has no shadow because the sun is perpendicular to Aswan on that date. So from measuring the shadow and the distance between Luxor, between Aswan and Alexandria at that time, and measuring the shadow there and the shadow in Alexandria and the shadow in Aswan, he calculated the circumference of the Earth for the first time in history. And he came to a very accurate measurement. He found it about 40,000 kilometers, while the actual value is 39,940. So it's very close. So he made a measurement for the first time of the circumference of the Earth with a very simple experiment. And then came Hipparchus. He lived half of its time in Egypt and half of its time in Rhodes. And they talk about Hipparchus that he invented the astrolabe. In fact, the astrolabe is a very important instrument that maybe you have seen during your visit to the center. And the astrolabe is an instrument with which we can measure the angles of the stars. We can see how the sky looks like. We can navigate with. We can see the time with it. It has about 12 or 14 different functions that we have now on our GPS systems and on our other electronic systems. But that was invented by the Greeks. But although it was invented by the Greeks, we have some writings from the Greeks about the astrolabe, but no astrolabe from the time of the Greeks reached us. I mean, they disappeared with time. And then the knowledge went to the Arab civilization at the time of the domination of the Arab civilization, and they became the manufacturers of the astrolabe, and behind them we have the oldest astrolabes in the world in the different museums. And we have some replicas of them in our center that you have seen, and maybe I'll give a lecture about that later on. And then came Ptolemy of Alexandria. He's a very famous, although he's called Ptolemy, he is not the Ptolemy, the king of Egypt, but he's a scientist. He's always called Ptolemy of Alexandria or Batlaymus al-Iskandarani. He is a magnificent astronomer. He made a publication that we didn't reach us, but the translation of it from the Arab reached us. It's called, in Latin of course, Magnum Opus, or the Arabs call it Al-Magest, or the Greatest. It's a catalogue for all the stars that he spotted at his time, with every star in the sky belonging to which constellation, and its longitude and latitude in the sky, and its brightness. So it's a famous table for archaeoastronomy, or for the history of astronomy. Of course, his measurements at that time were very crude, where he didn't have the exact or the accurate instruments that we have today. But with the accuracy that he has, it was not bad, and it was a good record and a good reference at that time. So you see how Alexandria contributed to the different knowledge of human being in astronomy at that time. Then came the Arabs. For many people, they consider al-Battani the most famous Arab astronomer. And there are many astronomers. The astronomy was an important science at the time of the Arabs because from the astronomy and from the geography, they can calculate the time of the prayer and how they orient themselves towards Mecca, etc. So that's why the astronomy and the geography was two very important sciences at the time of the Arabs. So they worked a lot on that. Al-Sufi al-Razi, he published a book called The Book of Fixed Stars, or صور الكواكب الثمانية والأربعين. I'll come to it later on because it's very important publication. We have a copy of it in our center. This is again, he took the work of Ptolemy, the Alexandrian Ptolemy, and he enriched it very much, and he made corrections of many things of it. So he takes every star and he says, Ptolemy said this is at longitude and latitude, so and so. No, it is at that and that, and its brightness, he said it's 3, no, it's 4, etc. So he corrected that, and he published a wonderful book that contains all the constellations that are in the sky. Constellations means abrag. We divide the sky into abrag, as we will see. And the Battani, in fact, he made tables also, and he corrected the Ptolemaic model, and his work reached Copernicus afterwards, and Copernicus referred to him many times in his publications. So, in fact, talking about the Arab civilization and how they treated, one of the main contributions of the Arab civilization also is mathematics. And up till now, all the Western countries, they use the numbers that we invented, and they call it the Arabic numbers, or the Arabic numerals. When this happened and how it happened, the main author of this, or the main personality of this, is called Al-Khwarizmi, from which came the word in computer that we use all, called algorithm. So Al-Khwarizmi was a mathematician and astronomer, and he was multi-knowledgeable person. And at that time, the Arabs were using different types of numbering up till that time. And all civilizations were using similar thing. At that time, they were using the alphabet to denote numbers. So the Alif is 1, the Ba is 2, the Gim is 3. So this is the Abgadaya, Abgad, Hawaz, Hotti, etc. Up till the Ya is 10. And then Kalamun, Kaf, Lam, Mim, Nun, the Kaf becomes 20, 30, 40, etc. So if you want to say 4, you write Dal, half Dal. It becomes 4. And remember that Dal is normally written like that. Or He, sometimes we write the He as a circle. And so on. So he invented, the Arabs were using this type of numbering, which is the alphabet, and the old civilizations, the same thing. The Greek were using the same thing, etc. As you remember, the ancient Egyptians and the Romans were using different notations. And if you want to say now 23, for example, then you take 20, which is Kaf, and 3, which is Gim. You write Kaf, Gim, it becomes 23, etc. It's important to know that because all the astrolabes and all the old instruments are carrying this type of numbering. That's why I'm talking about it here. So this is an example of how we say 10 is Ya, as I said, and then if I want to say 11, it becomes Yeh Alif, 12, it becomes Yeh Beh, 13, Hakaza, etc. So in fact, Al-Sufi al-Razi, when he wrote his book, he was trying to explain, to spot all the stars that are in the sky. Normally in the sky, as we will see, we try with our eyes, the sky is full of dots that makes the sky. And then we find out that some of the stars that are bright, and if we look at them, they form a square, with a tail, and so on. And then we started with our imagination. Imagine, like what we do today in Fingal, imagine figures in the sky. So that's why we call constellation or abrag. So a Borg is a collection of stars that forms certain figure in our mind that we call it الدب الأكبر, الدب الأصغر, the Big Dipper, the Small Dipper, the constellation of الميزان, Libra, constellation of Al-Asad, Leo, etc. So do you think how many constellations or abrak are there in the sky? How many constellations?
More than we know.
Huh?
More than we know.
More than we know. No, they are very fixed. They are very well known.
12?
12. Okay, the very famous one is 12. 12 is the zodiac constellations. Are the constellations, the sky is a sphere around us, but there is a constellations that are around the equator, they are 12. And the sun, in fact, because the sun is revolving artificially around the equator, so each month it's embedded in one of these 12 zodiac signs. So we call this month is the month of Libra, because the sun is now in the constellation of Libra, etc. But this is only the belt that is around the equator. But if we took, for example, the Big Dipper and Small Dipper, these are not part of the zodiac. When we look at البخت ما بنشوفش الدب الأكبر ولا الدب الأصغر، لكن بنشوف الأسد وبنشوف so on. So in fact, in the sky now, this is our division, I mean human being division of the sky. We identified 88 constellations, أو 88 برج. In the old times, they identified, we are talking about the upper hemisphere and the lower hemisphere. But in the old times, remember that we are living mostly in the higher hemisphere, so they identified only all the upper hemisphere and a little bit of the lower hemisphere, and they came to a 48. From the time of the Greeks to the Arabs, they identified 48 constellations. But today we know 88. So that's to say, we have divided the whole sky into 88 countries. It's like on the earth we have mountains, we have cities, we have so, but we divided every collection of things into a country. So we have Egypt that has so many cities and so many towns and so on. It's exactly the same. In the sky there is a constellation called the Big Dipper that has 8, for example, stars and so on. So one of the constellations that he identified in the sky, and we had imagined figures for that, is the constellation that is very famous. It's called Andromeda. It's this one. As you see here, there are stars. We feel that this represents the belt of the lady, this represents the hand of the lady, these stars here represent the other hand, etc., the leg, etc. And he numbered these stars, Aleph, B, standing for 1, 2, and in Latin we say alpha, beta, gamma, it's the same notation. So he says Aleph, B, E, D, etc. So that's why I'm talking about Andromeda. There is a very famous astronomical thing in the sky, in this Andromeda. Do you know, had anybody of you heard of Andromeda? Yes. فيها ايه Andromeda?
Heard of it.
Heard of it, okay. The Andromeda, in the constellation of Andromeda, there is one star or something that we thought it's a star at the beginning. It's the only galaxy that you can see with our eye. What's a galaxy? مجرة نسميها بالعربي. A galaxy is a collection, is a cloud, as if it is a cloud of millions of stars together into one collection. And we are on Earth part of a galaxy also. And the galaxy, does anybody know what's the name of our galaxy? Milky Way, exactly. We are part of a big galaxy called Milky Way, but because we are inside it, we cannot see it as a whole. We see part of it here, part of it there, etc. So the only galaxy that we can see outside us with bird eye is the galaxy of Andromeda. So in fact, we didn't discover that in the sky there are galaxies and the notion of galaxies except in the 20th century. Very recently, as we will see, we discovered that there is a galaxy in the sky called Andromeda, and there are galaxies in the sky. Of course, with the with the telescopes, we discovered hundreds or thousands of galaxies, but the only one that we can see with naked eye is the Andromeda galaxy. So in fact, that's why I am very fond of this Sufi Razi, is that he discovered this galaxy long time ago, but he didn't call it a galaxy. He found something. It seems that the Arabs, because they were living in the desert, and the desert is very clear, and they have very sharp eyes. We always talk in the Arab literature about the sharp seeing that they have. We don't have it today because we are bounded by buildings and so on. So at that time he discovered that there is a galaxy, there is a strange thing in the sky that he called it al-latha sahabiyya. That means a cloud, a batch of cloud. So he says, he describes in his book, as I said, he takes every constellation and he says this is Yeh Alif, which means the star number 11. Yeh Be, stars number 12. Yeh Gim, star number 13, etc. He goes one by one and referring to the figure I saw. And he puts here the longitude and latitude of that every star, and he puts here the brightness of every star. But in any case, he came to these three stars, Yeh Be, Yeh Gim, Yeh Dal, and he said, in Yeh Dal, this is near to Mulasiqa lil-Latha Sahabiyya. I believe that this is the first time in history that somebody spotted a galaxy. And remember that this is almost 1,000 years ago. 1,000 years ago, a Sufi Razi discovered that there is a galaxy, and he called it Latha Sahabiyya. And then, about 1,000 years later, we talked about it in the 20th century. So in the text also of the book, so this Latha Sahabiyya, this is Yeh Be, Yeh Gim, Yeh Dal, and it's just next to it. Now when I try to spot it with my telescope, where is the Andromeda galaxy, I go on the belt of, I try to identify the belt because these are three stars that make a belt of Andromeda, and then to the left of it I find Latha Sahabiyya, or the Andromeda galaxy. And then in the text he says, he talks about this Latha Sahabiyya or the galaxy several times in his text. And then came Ibn al-Haytham, that I quoted him at the beginning, and Ibn Rushd, they added to that. And then, as I said, came the time of the Renaissance. You remember that the Arab civilization, it was flourishing mainly at the end of it in Spain, and from Spain and the universities of Spain, they went to different places, and then came Copernicus, the first one who theorized that the Earth is the center, the Sun is the center, and the Earth, all the planets are revolving about it. And he theorized that, and this is his model. So now you see, we were talking 500 years BC that we talked about Earth is the center of the universe and everything is revolving about it. And then it took about 2,000 years in order to come to change the conclusion is that the Sun is the center of the universe, and it's surrounded by Mercury and Venus and Earth, etc. And the Earth has the moon around it and so on. And then came, so this is the old model and this is the new model. Now the Sun became the center, and as we will see, even the Sun is the center afterwards. So came Kepler, who has put the mathematical laws for that, and then came Galileo, who looked in the telescope, and what did he see in the telescope? He saw many things. The most important things, he looked at Jupiter, and Jupiter these days is very bright in the sky. If you look in the sky in the evening, there is a very bright star. This is Jupiter. He looked at Jupiter with a telescope. When he looked with the telescope, he saw around Jupiter, I will show you a picture of that in a moment, has 4 moons revolving around Jupiter. And then he immediately said that, okay, then there are moons revolving about Jupiter, they are not revolving about the Earth. So it's not everything revolving about the Earth. It can be revolving about anything else. So that was the first comment that he got. And also he saw that Venus, when he looked in the telescope, he saw that Venus has phases like the moon. It's sometimes full, sometimes it's half, sometimes it's a crescent, etc. So he said this can happen only if the Venus is revolving around the sun and we are outside it, which is the case. And then he looked at the moon and he saw the craters or the mountains that are on the moon and the other places that he called oceans, mare, and he sketched them in his notebook. And also he saw for the first time Saturn with rings around it. You remember Saturn has rings around it, so but we can't see it with our naked eye. So for the first time he saw these four things, and from that he postulated that the Earth and everything is revolving around the sun. So that's in fact the telescope that he used, Galileo, and it's now in a museum in Florence, in Italy, and I have visited this museum in fact. It's about 1 meter long. It was made, remember at that time there was no manufacturing, he did it himself. So it was made out of leather and paper and so on. So he made his own telescope. At that time, what he made him think of a telescope, or how did he invent it, they started making lenses, and the kings started ordering that they make small viewers with these lenses like the binoculars that we use today, in order that the king in his palace, he looks in the gardens and can watch the people going around the gardens if somebody is talking to somebody. It's watching, more or less. So he said, if I can see from far with these lenses, then maybe if I make the distance bigger, I can look at the sky and see things. So he did that. So this is Jupiter that he saw for the first time, and this is a picture of Jupiter that I took myself with 2 of its moons. It has 4 moons like that are revolving around him. And these are the sketch of the 4 moons going around. And if you ask me which planet you would like to live on for a while, other than Earth, I say Jupiter, because you can imagine we have one moon, and we are always fond of it. It's beautiful, the moon, it goes here, it goes there, it's half moon, it's full moon, etc. So you can imagine if you have 4 moons, then you play with, this one is crescent, the other one is half, the other one is full moon. But the problem is that when you love a girl, how can you tell her you are which moon of these? Okay, so these are the cycles of the 4 moons within certain months. The first day you have 2 here and 2 there. The second day you have, some of them goes very quickly. There is one that has a cycle of 2 days. Within 2 days it goes from one side to the other. They are fascinating. And this is Saturn that he saw for the first time. He saw the rings around Saturn. So that was the observations. And then he saw the moon with its phases and also with its oceans and with its craters that are here. So in the modern times, in order to finish, you remember, as I said, this is in year about 14th century, about 500 years, about 400 years ago, exactly 400 years ago. That's why I say this year we consider it the year of astronomy, the International Year of Astronomy, because of celebrating 400 years when Galileo looked for the first time there. So in fact, in 1576, they started talking, they were thinking that all the stars are in a sphere around the Earth, a fixed sphere around the Earth. So in 1576, Dix put a theory that no, the stars are not on a sphere, but they are in different levels. They are in 3 dimensions. Some of them are close, some of them are far, but they are all far away so that they look as if they are in certain level. And also in that time, Bruno came to a conclusion that all the stars are suns, that the sun is just one of the stars, and all these are suns, and since these stars are very far from us, but the sun is very close, we see the sun very big and the stars very small. So now the sun did not become a very special thing. It became just one of the suns that are around us. And as I said, Galileo invented the telescope in 1610, and then Halley in 1718. And do you know the name Halley? حد فيكم سمع على هالي؟ هالي في مذنب مشهور، عارفين يعني ايه مذنب كوميت؟ بيلف حوالين الأرض every 76 years. So they named it after Halley, one of the astronomers. He discovered that all the stars are in motion. Nothing is fixed in the sky, but in fact, the stars are in motion, but this motion, because they are very far, they look as if they are fixed. And then recently, Albert Einstein put his new theory, which is the relativity theory, E equals mc squared, and he combined the energy with the mass. And accordingly, they discovered that the universe is nothing but energy, and they discovered the black holes and all these things. Maybe we have another time. And then in 1924, a scientist called Hubble defined the galaxies. You see, Sophie Razi was talking about that 1,000 years ago, about the اللطخة السحابية, and Hubble just discovered it in 1924. And do you know the name Hubble also or not? Anybody here? This is a telescope that we have sent outside the Earth cover, or the Earth atmosphere, in order to have a clear look at the other planets. And then finally, George Gamow in 1940, just 60 years ago, formulated the Big Bang Theory, which says that now that the universe is a big container that has galaxies all the way around, and that it is expanding, that it started, so the sun did not become the center of this. And one of these galaxies is thus our galaxy, which is the Milky Way, and in this Milky Way, we have the collection of stars, of planets of the solar system. The Earth, the Sun are surrounded by Earth and by Saturn and by Jupiter, etc. So all this system or solar system is just a point in our galaxy, which is the Milky Way, and our galaxy is just one of millions of galaxies that are around the universe. So the three steps are the three basic concepts along history of the cosmic model. The beginning was that the Earth is the center of the universe, and then it became the Sun is the center of the universe, and then it became there is no center for the universe, but there is a big universe that is expanding all the time, and so on. Okay, with this I finished my first part of what's astrology and what's astrophysics and what's archaeoastrology, etc. Thank you very much. This time we will talk about basics of astronomy. In fact, you remember the last time we were talking about that finally in the 20th century, remember that it's just now, this is the image we have in the 20th century, and 21 of fusion, that the universe is a big bubble or a big ball that contains lots of galaxies, and in every galaxy, lots, that means millions of galaxies, and in every galaxy there are millions of stars, okay? And one of the galaxies is our galaxy. So in fact, all the stars that are in the sky that we see with our eyes around us are part of our galaxy only. So what we can see with our eyes is the stars that are part of our galaxy. And that's what we call the near sky. The near sky is the sky that we see with our eyes, and all of it is part of our galaxy. The deep sky, what we call the deep sky, is other galaxies and other stars that are far away from our system or from our galaxy, and we cannot, in fact, we cannot see it without telescopes, without complicated machines. So this is the difference between the near sky and deep sky. What we see here in our galaxy, which is this one, is the near sky. But what is deeper than that, we call it the deep sky. This is as simple as that. So the near sky, it contains, as we know, stars. It contains constellations, and as I said before, the constellations, or al-abrag, is a collection of stars exactly like what we define on geography with countries and cities. Cities are different cities that are around, you can look at it without borders, and then when we put borders around set of cities, it becomes a country. Like Egypt, it has Luxor, Aswan, Alexandria, etc., and so on. So the constellations are equivalent to countries. So in the world, in our on the Earth, there are now around 200 countries. We have about 200 countries. In the sky, as I said last time, so we have 88 constellations. And then I'll talk about the zodiac signs, which are a special group of constellations that are around the belt of the equator. And then I'll talk specifically about our solar system, which are the planets. And then I'll talk how we divide the sky, like what we did on Earth exactly. On Earth, as you know, we divide the Earth into longitude lines and latitude lines, and with these lines we can locate any position on the Earth. We do the same thing with the sky. So there are two systems, and I will explain why. On the Earth we have only one system, because we have one reference, which is the North Pole and the South Pole, and we decided to select another reference, which is Greenwich line, which is the reference, the zero line. So horizontally we have the Greenwich zero line, and vertically we have the North Pole and South Pole as references. But for the sky we have two systems, and we will explain why. So if we look at the sky, for example, as we will see now pictures, we will see sky full of stars. But when you look now at the sky normally, under normal conditions, like in Cairo or in Alexandria and so on, you don't see that much stars. The only planet, but not star, you will see clearly now in the sky if you look at it in the evening, is, as I said, the Jupiter star, Jupiter planet. But why we don't see now, and in the old times they talk a lot about the sky and the constellations, so on, and now we don't see that, because there are things that makes vision much less now than before. Number one, the city lights. When you have lights in the city, then this makes as here, for example, we have lights. We can see the picture in some way, or the screen in some way. If we close the light, we see it better. We put light, we see it less. Put light, we see it less, etc. So it's the same thing with the sky. As we have city lights, this reduces the vision of the sky. Also, the atmospheric conditions. If we have, like in the morning, sometimes we have fogs, we have things like that. This renders looking at the sky. Also, the pollution, and we have a very nice example of pollution, as Sahaba Soda. When there is Sahaba Soda, you don't see anything in the sky. And of course, the clouds, it hides the sky. And one of the important things, even if the four conditions that I said before, there is no city light, there is no atmospheric conditions, there is no pollution, there is no clouds, then your latitude or your height on Earth is very important, because as you go higher on a mountain, then you have less atmospheric layer, and you have less filters that filters this, and you see better. That's why they normally put the observing points on the top of the mountains and so on. المرصد. So that's why I'm just explaining. That's why after this lecture you will go, I know, this evening and go and try to look in the sky, but you see very little. But if you go in the desert, as I said before, you see much more beautiful sky. Okay, so as I said, Ptolemy the Alexandrian and Sufi al-Razi and al-Battani, they made tables, and in these tables they said every star is at what longitude and what latitude and what is its brightness. And in fact, they express the brightness now in terminology that we use scientifically. They call it magnitude. So in the old times, we didn't have instruments to measure the magnitude of the brightness or the magnitude of the star. So what they did is empirically, I mean visually like that, they say this is very bright, this is less bright. So they divided the scale of brightness that we see with our eyes into 5 levels, from 1 to 6, between 1 and 6. So they say this, if it is very faint, they call it magnitude 6. That means this is the threshold of the eye, or the minimum level that the eye can see. It's magnitude 6. And then the brightest star in the sky, which is in all the times, it's the star that is called Sirius. They give it magnitude 1. And then they estimate any other star that it's 2, it's 3, so it's subjective. It's not really measurable, but it's subjective. But in the modern times, between the brightest star and the faintest star, we divided it into 100 times of magnitude, and we used the logarithmic scale. So finally we came to 5 divisions, but we can measure now, we can talk now. In the old times they always say the brightness of the star is 2, it's 3, it's 4, it's always integer number. But now, because we use measuring instruments, we say this star, its brightness is 2.5, is 3.6, etc. I said that the faintest star was 6, so the minimum star that we can see with our eye, we say that is magnitude 6. But now, with the telescopes and with the other instruments, we can see fainter stars than that, so we can see a star of brightness 8 or 10 or 12, depending on the power of the telescope. So this is what we call magnitude. It's very important. Stargazing. When we look at the sky, what do we see really? In fact, I put all the lights off in order to see better. If you look at the sky, this is the stars that you will see. Maybe this is Sirius, the most bright one. So at large, if you look at the sky, especially when you go in the desert and in a day that there is no moonlight also, it becomes puzzling. You see a sky that is full of dots like this. It's like, as I said, when you look at the Earth and see cities, but you cannot identify. In order to say the cities, where is this city? At large you say, this is in Egypt, or this is in England, and so on. So here, the first thing we decided to do is that we try to form, for example, this is in fact a Sirius, they are the most bright one. This is Orion. There are bright stars here, 1, 2, 3, 4, 5, and there are 3 in the middle. So we made artificially with our eyes, imagination, that this is something. So that's what we call constellations, or what I said, and this is arbitrary, by the way. So this is the one I was talking about, Orion, and this is the star that is here. And then in the north here, you can see there is the Big Dipper is here, Ursa Major, Big Dipper, the 4 stars and the tail of it, and the Small Dipper, which has the most important one here is the polar star. It's not because it's very bright, but because it is aligned with the axis of the Earth, so it's fixed in the stars. All as the Earth rotates, then all the sky rotates around it, around this point, which is here. So as I had shown that these are the stars, just without interfering from us, and then we try to collect them into countries as we did in geography. So every collection we connected together with our eyes, and we see this is the Big Dipper, this is the Small Dipper, for example. And remember, this is around the equator. So you have here Leo, or the lion, Borg al-Asad. You have here Borg al-Tawam. There are two stars here, that's why we imagine here there is a lady and two ladies or so. There is Borg al-Tor, or Taurus. Here is Borg Cancer, or Saratan, etc. Here is Borg al-Azra. So the constellations that are around the equator are the zodiac signs that we know. But you see in the sky there are many other constellations or many other countries. So these are what we call constellations, and we have 88 constellations like this around the sky. And then we started giving the stars and the constellations names. And here, maybe I'll show you a very fascinating thing. For example, here, if you can read it, this is, in Arabic we call this constellation Dubb al-Akbar. And then there is a star in all, this is a Western constellation. There is a star here called Dubbe. So we give the constellations and the stars names, like this one is Sirius, like etc. Canopus, and you have many, and many names are Arabic names. This one, for example, Al-Fard. Al-Fard means the unit, Al-Wahid. Al-Fard. This one called Ghurab. This one called Ginah. And this is an American program. So that shows that the Arab influence is there because they were the masters of astronomy for many hundred years. And then I added in this vision that around the same level of the equator are revolving the different planets. So we don't see all of them at the time, but we see some of them because some of them are in front of us and some of them behind the horizon. So for this one, we have here Saturn in this position, we have the Sun in this position, and maybe others. And then we have, I'm adding layers, as I said. As I push a button, I add a layer of what we call deep sky. Deep sky is other galaxies. We normally give them sometimes names and sometimes we give them numbers. So we call it M47, M48, M so and so. So these are galaxies that really we cannot see except with telescopes, but we cannot see with naked eye. And then comes the idea of the axis that we talk on. As I said, on the Earth we have in any two-dimensional thing X and Y, or polar system that we have, like we have on the longitude and latitude on Earth. So the problem on Earth is that we have North Pole and South Pole, and we concentrate on that, and that's it. So the equivalent of this in astronomy is that we divide the sky. Again, we take the North Star, or the polar star, as a reference, and around this polar star we have circles like the latitude, and then we will have longitude lines. So these are latitude lines. So here you have a line that is 0, and then here plus 15, plus 30, up till plus 90, exactly like on Earth. At the Khat al-Istiwa, at the equator, it's 0. and then it goes up to 90 at the polar, and then minus 90 at the southern polar star. And then you have longitudes like the other one, but here the longitudes is peculiar because as the Earth moves, in fact it makes a complete circle in 24 hours. So we divided the longitudes lines into 24 lines, and we call it hours also. So this is 0, then 10, 2 hours, 3 hours, 4 hours, till 24 hours. So we have 24 longitude lines, and we have 90 latitude lines, horizontal, upper and lower. And then if we have a star here, for example like this one, we say this is at this longitude and this latitude, okay? Exactly like we do on the Earth. But here comes another question, is that I'm taking the North Pole, or the extension of the North Pole, the pole of the star, as a reference. Then some other people said, no, I have the stars on the top of me like this, and I have a middle point in the middle here that is the reference in the sky, and then from this I make my measurements. So there is another way of measurement, is that the center is the center of the sky on the top of me. And then from this I have circles around me, and I have lines perpendicular to it. And this is the second way, which we call the azimuth. So in fact we can locate a star in the sky either by the polar system or by the azimuth system, okay? But in any case, the tables that I was talking about is normally belonging to the first system, which is this, because everything is fixed to the other in this figure. But in any case, so the tables that Sophia Razi I had shown, it shows longitude, latitude, and brightness. But Ptolemy did the same thing, and so on. Okay, now let us talk about the solar system and planets. And I think you might know this by heart from the physics that you studied in school. As we know, we have the sun, and then around the sun circulating Mercury and Venus, and then the Earth. So Mercury and Venus, we call them inner planets. They are between us and the sun. And then other planets like starting Mars, and then Jupiter, Saturn. All these 5 can be seen, as I said before, by the naked eye. We don't need binocular or telescope to see them. We can see them by our eye. And then we discovered, when we had telescopes, that there are other planets like Uranus and Neptune and Pluto. And maybe you heard about the story that Pluto is now excluded from the system, because it's not because Pluto does not exist, it exists as it is, but they have defined what is a planet. A planet must have minimum weight and minimum mass and minimum diameter and minimum this and this, and so Pluto does not apply to this, so in some references they removed it. These are the distances of these planets from Earth, from the Sun, and these are the inner ones and these are the outer ones, as I said before. And it follows a certain arithmetic theory, and maybe we'll talk about it one day. But if we follow this theory, we find that there should have been a planet here in between Jupiter and Mars. So this is missing planet. It seems that it was a planet and it was bombarded and became asteroids or small pieces. So there are small pieces around in this place between Jupiter that we call asteroids. Okay, this is the relative size of the different planets. This is the Sun. If this is the Sun, then next to it in size is Jupiter, as you see here. And next to Jupiter there is Saturn, and then there is Uranus. You see, Uranus is much bigger than Earth, but because it's very far away, we don't see it with the naked eye. And then Neptune, and then etc. And then here is the Earth and Venus and Mars, etc. Normally, we say that Earth and Venus are sister planets because they are very close in size to each other and neighboring also. So here we have a table in which we have the different planets. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 planets. And if we take the Earth as a reference, as 1, then if we measure the distance from the Sun, then if the Earth is 1, then Venus at 0.7 this distance, Mercury at 0.4, Mars at 1.5, etc. If we look at the diameter, the Earth is 1 and Venus is 0.97, so it's very, very close. The mass, the Earth is 1 and Venus is 0.81. That's why we call Venus the sister planet, because it's very close to the Earth. And then every one of them rotates around itself. So if we take the Earth as reference, which is 24 hours, and Venus returns in 243 days, make one revolution in that, etc. If we take the Moon, as I said, the Moon, we talk about it as it has different phases and as it has different houses. I'll say what it means. And I'll talk a little bit about the story of the new moon, how we decided. So the phases of the moon is, as we know, the moon is sometimes in the middle of the month, full moon and half moon and 1/4 of a moon and so on. And then when we looked at it with telescopes and with detailed thing, we started making a map for the moon and calling some of the mountains or craters, as they call it, into the names of the scientists that worked in the field of astronomy. So here, for example, you find Aristotle. It has one crater here called Aristotle. There is another crater, of course this is our names. Ptolemy, there is a crater called Ptolemy, etc. There is a crater called Julius Caesar, even characters. Aristarchus, the Greek, is here, etc. And then recently, because the Western countries, of course this is 20th century naming, because the countries in the West are now belonging to, they feel that the Greek civilization is their extension, then they have put the names of the Greek scientists here, and also they put the Western scientists, Copernicus and Kepler, etc. But recently, because Dr. Farouk Baz, was working with the NASA, and when they discovered the other side of the moon, the back side, after they have sent a satellite there, he imposed some Arabic names on some of the craters on the back, some of Arabic scientists. So this is the full moon, and as you see, it's full of what they call oceans, which is in Latin mare, or the craters, which are mountains that are around. So these are, as I said, the last part is the phases, that the moon has phases, as we call them. But the moon, in the meantime, while it goes in the sky, it's coinciding with different zodiac constellations. As the sun also, during the year, is residing or living in each month in one of the constellations, zodiac constellations. That's why we say we are now in the zodiac sign of Leo or zodiac sign or Sagittarius, etc., because the sun is living there in this month. And the moon has the same situation. It has 28 positions that were defined by the Arabs. They call them the houses of the moon. In fact, the zodiac signs are the houses of the sun. So there are zodiac houses for the moon. So we saw the sky, the stars in general, how it looks, and we divided it into constellations, which corresponds to countries in our case. And we said that around the equator are the different planets appears. The stars are fixed to each other, but the planets are moving all the time. I mean, they change position all the time. That's why the sky maps contains normally only the stars, and then we see the condition of the planet and we see where it is. And then we have the deep sky. As we said, deep sky is normally we talk about galaxies. We talk about clusters. Clusters is a galaxy is a cloud of millions of stars, but a cluster is a collection of few stars, 10 stars, 20 stars, and the most famous one is called. They call it the Seven Sisters. Have you heard of them? It's called scientifically Pleiades, but normally they call them the Seven Sisters. The Greek, they imagine that there are 7 stars, bright stars, close to each other. In the religion of the Greeks, they consider that these are 7 sisters that were belonging to one of the gods, of their gods, etc. So they call them simply 7 sisters, and they call the cluster Pleiades. So the difference between galaxies and the clusters, the galaxies is a cloud of millions of stars. The cluster is a collection of normally few bright stars, like 7, 10, 2, 3, etc. So I remind you all the time that when we talk about near sky, we talk about our galaxy, all the stars that we see with the naked eye. When we talk about deep skies, we talk about the things that we can only see with normally with telescopes and with helping aids. Okay, so this is our galaxy, and we can identify. We cannot see it as it is illustrated here. This is our reconstruction of it, and we can see in it the sun must be here, and this is the arm of Orion. That means the constellation Orion is falling into here, and this is the Cygnus arm. Cygnus is one of the constellations also, etc. So this is the different constellations in the sky are surrounding our parts of this Milky Way or our galaxy. Now, just a little talk about telescopes. As I said, there are in fact 3 types of telescopes that we look with at the sky. The first one that was constructed by Galileo in the old times and still in the market up till today, by the way. It's called the refractive telescopes, which has 2 lenses, one eyepiece and the other is object-piece or objective, and then it depends on the focal length and the diameter of this, how much we can see with it. And then we have a reflective one that we will see, and we have 2 types of reflective one. So the first one is based on the idea of Galileo, or sometimes they call it Galilean telescope. And here it is the idea. You have here one lens and here another lens. This is called the eyepiece and this is the lens. And the light comes from the star like this, and it's collected on the eyepiece, and we can see it with it magnified several times, normally about 100 times. And this is a typical telescope that you have in this refractive model. And then Newton, the famous scientist Newton, has invented another telescope which has a mirror inside it, so that the light comes from here, comes on a mirror, and then a secondary mirror, and then reflects to the eyepiece. So as if the beam is traveling twice, as if its length is twice the length of the physical length of the telescope. So it magnifies 2 times as much as the same telescope that was used by Galileo. But the advantage of this telescope, in fact, it gives bigger magnification, but it's very convenient in watching because the other telescope, as you see here, you have really to lean down in order to look in the eyepiece, in order to look at the sky. But this telescope, which is Newton telescope, you can look in the eyepiece, which is here, just at your height like this, and you look vertically. It's very convenient in watching the sky. And then came a third type, which is very popular now. It's called the Schmidt-Cassegrain telescope, which has 3 reflections instead of 2 in the case of Newton. So the beam comes like this, and then it's reflected second time like this, and then reflected third time like this to the eyepiece. So the length of this telescope, it's as if I have 3 times its length in case of Newton, in case of Galilean telescope. So these are the 3 types of telescope that we have in the market. But there is another feature in the generations of the telescope. The telescope, the first part is manual, and this is the normal telescope like Galileo. Remember that the Earth is rotating, so everything in the sky looks as if it is moving clockwise. So in fact, when you look, when I have a telescope, a normal telescope, and I'm looking at certain star, this star is at this position now. After half an hour or maybe 10 minutes, it moves a little bit to the right. So if I have telescope, then I have, and watching the same star in 10 minutes, then I have to move the telescope to the new position of the star. So I have all the time to move the telescope. So that's what we call manual. So in fact, recently, about 20 years ago, they invented telescopes that has a motor in it, so that the motor rotates, makes one rotation every 24 hours. It's very slow, so that it compensates for the rotation of the Earth. So if I put it looking at certain star, as the star moves, the telescope automatically moves with it. So this is what we call motorized telescope. And then about 10 years ago, with the computers and the microchips and all the advancement that is happening in IT, they invented a telescope that is computerized. And computerized, that means it has also GPS in it. Are you aware of the GPS, what the GPS is?
Yes.
Yes. Okay, and now we have it on our telephone and in everything. So the telescopes now that are produced these days has a GPS in it, so that it locates automatically where you are, and then it adjusts itself to the sky to the point you want to go. So they call it a go-to telescope. You punch on the keyboard that I want to go to Mars, for example, or to Jupiter. Then it calculates where you are automatically with the computer and where Jupiter in the sky is, and it orients itself immediately there, and you look in the eyepiece and you immediately see Jupiter or the one you want. Maybe I show you the last thing is just appearing this year. I got my telephone that has on it like any other telephone, and it has maps and it has all these things, but because I'm interested in the sky, then I have a sky map also, and it has a GPS and everything on it, so that when I look, I hope it comes, yeah. When I look at the sky on this one, when I look at this direction, this is the constellation that is behind my telephone and the names of the stars and everything. If I move it here, then I look in another view and I have another thing, and so automatically, okay? So this is just a production of this year, because the telephone became, as part of it, GPS, and part of it compass, and part of it maps and everything. And finally, the last thing I want to show, astrophotography. Astrophotography is doing photography through astronomical equipment like telescopes and so on. So normally we adjust our normal cameras, we have certain adapters that we put on the telescopes, and we can take some pictures like this. These are my pictures. This is the moon with Venus. They were close to each other at one moment. This is a vision of the sky with the stars without lines, because of course this is just a picture. This is the details of the moon with the craters, etc. This is another details of the moons. And that's it. Thank you very much.